plan. Kind of just working on what we've been working on in terms of like eliminating fractions, trying to just fraction bust. Again, I think some of you guys are already really good at this, and probably this lesson will seem really easy and kind of a step back, like hopefully yesterday did, or I'm sure I should say Tuesday did. Anyway, creating integer coefficients. Often one of the best ways to deal with challenging tasks is to find a way to make the task easier. For example, lifting a heavy weight can be made easier with a lever or a pulley. Mathematical problems are very similar. Often a challenging problem can be changed to create a new problem that is easier to solve. In this lesson, you will develop strategies for rewriting a complicated equation into an equivalent equation that is more familiar and easier to solve. So, community service. A community service club at North Middle School is planning to paint apartments at the local senior citizen center next week. The club needs your help to determine how many apartments they should be able to paint in a day. Earlier in the year, when only 4 of the 7 students worked, they painted 9 apartments in one day. Next week, all of the students are available, so I think the assumption and the hope would be that they'll be a little bit faster, right? That they'll get more done. So assume that all the student workers contribute equally to the work. If X represents the number of apartments that can be painted by all the students in the club, use a multiplier and your understanding of scaling to represent this situation in an equation. Well, if you think about it, we're essentially saying 4 out of 7 students worked, and when they work, they got 9 of them done. So hopefully when they do 7 out of 7 workers, that number will increase. But this is the total workload. We multiplied it by 4 sevens. So it was smaller, we would think. So choose a strategy to solve your equation in part 9. What does your answer represent? Well, of course, there's a bunch of different ways to do this. But I think you know how I'm going to try to solve it. I am going to multiply by the reciprocal. I'm going to hope to cross-cancel, which sadly there is no cross-canceling, which makes me super sad. I'm going to get 63 over 4. If I divide that, right, I know that 4 times 15 is 60. So I have a remainder of 3. So 3/4, so 15.75 apartments. Now I'll kind of assess, does this make sense? If 4 people got 9 done, I would expect to do a bit less than half. And 9 doubled is 18. This is a bit less than half of 18, so I feel pretty good about that as an answer. So how can I make holes? Janice, the club's president, began to think about how she could visualize 4/7 x to help her solve her equation from problem 751. She recalled using algebra tiles to represent x. In her mind, she visualized the diagram at right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 there, right? There's our 4/7 on this side. There's our 4/7 x. Uh-oh, got my stylus pen upside down. So there's our 4/7 x, and there's where it's equaling 9. Does the equation, Matt, represent your equation in problem 751? I would say yes, right? That was the equation that we came up with. Janice recognized that these numbers were not easy to work with since she did not have whole tiles. After working on her paper for a while, she said, maybe I can make whole tiles using more than one set of partial tiles. She drew the diagram right, and you can see we have 1, 2, 3, 4, 5, 6, 7 sets of these, right? And that equals that many. So what is the new equation that she's going to have there? Well, there's 28/7. So it looks like we have 28/7 is 4. So 1, 2, 3, 4, 5, 6, 7, 8. 12, 16, 20, 24, 28, right? So we have 28/7, so that's kind of like 4x, if that makes sense. And that's going to equal 63. I hope that makes sense again. Kind of what we're doing here is we're saying we have 4/7, but we have 7 sets of those. So we actually have 28/7 that are grayed in, right? So that's the same as 4 total. If we had extended these things out, we would have 4 total sets of them. If you disperse these 28 across, I think I'm making this worse and I apologize for that, but if we had dispersed these 28 across tiles of 7, that would make 4 total X's if these whole things were all shaded in like that. So that's kind of what we're saying. And you can see that that shows up in our math up here, right? We had already kind of done that up here where we had said that we were dividing by 4. So long story short, that's a fancy way of they took just to show what they did, because I feel like this is so convoluted and I do not love the way they taught this. Essentially what they did is they multiplied both sides by the denominator and they said, hey, 4x is equal to 63. I hope that makes sense. If you followed this, awesome. If you didn't, that's what they did. So at that point, it says, with your team or class, discuss Janice's strategy for solving this equation. During your discussion, answer the following questions in any order. What made Janice's strategy different than what you did in lesson 714? So she's making whole x's, right? She's making whole x's where I don't know, we have it's called the integer coefficient. We give a whole number coefficient instead of a fractional coefficient. If it's 4/7 x equals 9, this is a fractional coefficient, but people feel comfortable with a whole number coefficient, so that's what we did. So that would be one. And then how many sets of 4/7 did Janice use to get a whole number of algebra tiles? Well, she used 7 sets, right? And I don't think that's an accident. She used 7 sets because that's the denominator. And why did the right-hand side of the equation change? Well, it's balanced. Right? It's balanced, and if you're going to multiply one side by 7, you have to do the same thing to the other side. And how does the number of sets Janice used relate to the equation you wrote? It's the same as the denominator, the fraction, in the equation. I can't say this enough. Everything that happened here is a really elaborate way of saying, hey, when you get a fraction set up like this, if you just multiply it by the denominator, the fraction will go away. It's known as fraction busting. Again, like I said, we pretty much have taken it past that step already, and we have decided that we are going to multiply by the reciprocal and actually do 2 steps at once. As you can see, hopefully or obviously, the next step would be divide by 4. And maybe get x equals 63 over 4. So you can see the first thing they did was multiply by 7. First thing was they multiplied by 7. And the second thing was they divided by 4. If I go back up here, you can see what's happening. Yeah, I'm missing. You can see the first thing we're doing is multiplying by 7. And the second thing we're doing is dividing by 4. So I don't know. It's all so convoluted. I don't love it, but it is what it is. So, will the strategy of turning fractions into integers from problem 752 work with other equations such as 2/3 x equals 8? And yeah, I think hopefully we already know that it will. We could multiply. Anyway, so it says how many sets of 2/3 x would make a whole number of x tiles? Well, we'd multiply by 3, right? We would say, hey, look, we have 2/3 x. 2/3 x equals 8. I'm just going to say 8. So if I do this 3 times, you can see, oh, hey, look, I have 1 set of 3 and I have 2 sets of 3. So 2x would equal 24. And again, if I just take the original equation, 2x over 3 equals 8, and just multiply both sides by 3, 2x is going to equal 24, right? So that's what we're doing here. So how many sets? We would need 3 sets. Solve for x using this method. Well, if we divide by 2, x would equal 12. And then show how your solution is also the number of 2/3 in 8 holes written 8 divided by 2/3. So I guess 12 2/3 is the same as 24 1/3, which can be regrouped into 8 holes. I'm reading the answer key. Like, this blows my mind that they think this makes it easier to understand. And I apologize if it does make it easier to understand. I don't mean to make light of it. It's just my brain works so differently than this. Like, if this is how I learned this stuff, I would be cooked. I would have no idea how to do fractions at all, I think, because this is so convoluted to my brain. So anyways, 12 2/3 is the same as 24 1/3, which is true, right? 12 2/3 equals 24, and 24 1/3 equals 24. So, I mean, that's true. I just don't know that helps me. Anyway, moving on here. Janice wondered if the method of creating whole number x terms would work with decimals. Suppose an item was marked 15% off and the sale cost was $36.21. She wrote the equation 0.85x equals $36.21, I guess. Okay, so hopefully we understand what's going on. Why did she write 0.85 in her equation? Well, I'm going to go back to a black pen, by the way. So hopefully we remember, if it's 15% off a price equals keeping 85% or paying 85%. I know we've discussed this before. We start at 100. So if you start at 100% and you're getting a 15% discount, that means you're paying 85%. So that she decided to do the shortcut that we talked about. Is there a number she can multiply both sides of the equation by to get an integer coefficient so there's no decimal? I hope you guys know decimals well enough to know that multiplying by 10 doesn't get it. Multiplying by 10 will only make it 8.5 and 362.1. I actually need to multiply by 100, right? If I multiply by 100 on each side, it will turn into 85x equals 3,621. So hopefully that makes sense to you guys. So yes, the number is multiplying by 100. And what they're just trying to show right now is that you can get rid of decimals the same way you can get rid of fractions. Use Janice's strategy to solve the equation. What was the original price of the item? Well, I guess at this point we need to divide 3,621 by 85. So thanks for that, book. I guess 85 goes in here. I'm going to guess 4 times. So 0, 2, 32, 34, 2, 2, 1. And then I guess we're going to say 2. So that's going to be 170. And at that point we're going to meet our decimal. So if now I'm at 510. So I think, it's at least going to be 5. 5 is going to give me 425. I'm going to try 6 and see if it works to 6. I have a suspicion 6 is going to hit exactly there, and it does. So 42.60. So it looks like the original price of the, it looks like the original price was 42.60. And then does this method work for all equations with decimal coefficients? So yeah, on this one we could multiply by 10 and we would get 12x equals 140. And on this one we could multiply by, hopefully we see it as 1,000, and we would get 999x equals 7,1. Now we have to move the decimal 3 places, right? 2, so that was 1, 2, 3. So we can get that equation. I don't know if it wants us to solve this, but if it does, I'm going to let you guys handle that. And then finally, 755. Solve each equation below by changing the number x. So what they want you to do is multiply by 6 and then get 5x equals 24 and then divide by 5. So x would equal 24 fifths. You guys know I would do that in one step. This one, actually I guess I should go to B. This one they want me to multiply both sides by 10. And I would get 8x equals 190. Then I'll divide both sides by 8. And I'm going to get, I don't know, doesn't seem to work out evenly. So 2, 16, 30. So we'll say 3 is 24 with the remainder 6. So 6 eighths is 7/5. So 23.75 is going to equal x. On this one, I'm going to multiply by 3. And I'm going to get 5x equals 36. I'll divide by 5. It's really nice to have all these work out well for us. So I get 36 over 5, which, if we care, I mean, I could call this 7 1/5, and I could call this one 4 4/5, but that's not really necessary. We don't have to do that. And then finally, this one I can multiply by 100. So I'm going to get 12x is equal to 100. I'll divide by 12, and I'm going to get x equals 8. 8 times 12 is 96. So I'm going to have a remainder of 4. So 4/12 is 1/3. So I'm just going to 8.3 repeating. So hopefully that makes sense. Again, I don't love this method. I think we're a little bit further along than this, but I do think it's worth going back. Maybe trying to help some of the ones that are struggling a little bit. Hopefully this helps if your brain sees it that way, even if mine doesn't. Thanks.